Hello again. In this video, part 4 in the series, we will construct a scarf joint joining two boards at a predetermined angle. This need crops up many times in a boat building project. Here are a few examples. Here's a couple examples of patterns that I've made using this joint. As you can see right in this area, this pattern, which is was the pattern for making the face between the keelson and the keel, I would have had to use at least a 10-inch board, and I got by with something about 6 inches to be able to make this pattern. This one I think is the bottom edge of the shear straight, and it survived several patterns. I used it for like the guard board, and then I cut it, readjust the shape to match the next board, and put a kink in the pattern where necessary to make it match. Here's a scarf joint in one of the strakes. There's dozens of these in the hull here. Not one of them was straight. Here's another one in a wire board. I'd estimate, since each of these strakes cost me around $100 in material, by using these kinked scarves I've probably saved at least half the material, so that's pushing a couple $1,000 worth of savings by being able to use kink in the scarf joint. Here's a trial run of the stems for my boat. This one was made out of some pine, and it's made by laminating several boards together, each of which had one or more scarves in it, so that I could create an arc and eliminate some of the wood. The final oak stems are built similarly, and they have dozens of kink scarves in them. We wish to find a geometry that allows us to generate a kink in our joint, but at the same time allows us to actually construct the joint by using our stacking technique. I did this off camera, and so now we have two non-rectangular scarf surfaces that were, when put together in a stack fashion, form a constant slope. And if we flip this over, we see we do get our kink joint. But you see, both surfaces are identical, but they're not symmetric. What's going on? Let's put our joint back together, and we could glue it in several different places. Let's go ahead and glue it so that this feather is completely lined up with the full length of this stripe. After we got it glued, of course, we'd nip this off. Look what happens on the other side, though. This board, the scarf, in effect eliminates the use of this much of this board. So in a sense, we lose width when we create a kink scarf. If we make both sides about equals, in other words, these two tips here are sort of like butterflies, then we'll lose a little bit on both boards. And it turns out that kind of maximizes the amount of effective width that we have. But the purpose of this joint, remember, was to put a joint in so that we didn't have to use as wide of boards. And then when we use the joint, we end up, in a sense, overcompensating, because the effective width is less than the actual width of the boards we use. So we have to consider this when we're laying out our patterns. This effect is smaller when the scarf kink angle is less, and so often it pays to put two scarves in instead of one large one. Now I've blackened in the areas that we can consider as waste, and you see what we end up with is two rectangular scarves, and that explains the dilemma why the two scarves in appearance don't look symmetric, but the effective portion of the scarves are rectangular and therefore they are symmetric. We can call the angle of change in direction of the edges of our two boards, we can call that the kink angle. And what's the relationship between the kink angle and the angle between the edge perpendicular and our strike? That was what we called the strike angle. Well, it turns out it's kind of reminiscent of the bird's mouth joint, where the bevel angle was 1/2 of the stave angle. It turns out the same thing here. The change in direction, our kink angle, is take half of it to end up finding out what this strike angle is. But in our construction technique, you'll see that we don't really have to do any of that math. Enough theory. Let's go ahead and make a scarf with a kink in it. I've got a pattern here and I've got it laid out on a flat surface, and I've adjusted it, and we can see that there's so much curve in this pattern that it looks like we'd have to have about a 7.5 inch board to be able to cut it out of one piece, and even then we would have a good section of it where we would have a lot of cross grain, which would weaken it. So this is a prime candidate for putting in one or more kinked scarves. Let's say we got a lot of 3 1/4 inch stock, and what we do is we position some scraps and get them in position, and we determine that it looks like we're going to have to make 2 scarves to make this work. What we want to do is mark out, cut, and glue each scarf separately to make sure we don't get creeping air. So we'll go ahead and start with the first scarf joint. Make sure the end of your scrap is square, and then go ahead and mark off that edge on the underlying board. I've removed the pattern for now. We don't need it anymore. Now we'll take this line here, which was perpendicular to one board, and we'll draw our edge perpendicular on this one. This ends up being our kink angle. Our next step is to bisect this angle. When it's this small an angle, we can usually just eyeball and be plenty accurate. This angle then is the straight angle, and we can pick it up with the bevel gauge, and then we'll transfer it to the end of our boards that we're going to scarf together. So we'll draw in the feather on both of our boards. Instead of finishing this demonstration in pine, I'm going to switch over to plywood so we can see the scarf faces. Okay, I've cut the feather now to the proper strike angle, and now would be a good time, if you're so inclined, to butt joint your scarf and lay your pattern on top of the pieces to see if you're satisfied. Make sure you allow for the overlap. If everything's good, then our next step is to decide on the location of our strike line. If we're going to use an 8:1, this is 1/2 inch plywood, so if we're going to use an 8:1, that would come in about 4 inches. Want to measure that, measure perpendicular to the face, to the feather, not along the edge. So each one would be about right there. So that's where we'll draw a strike line in. Go ahead and make some witness marks. Then lay your other board on top, lining all the edges up. And then go ahead and transfer the witness marks onto the other board. And go ahead and draw in the other strike line. Before you start your scarf, lay your work back out and decide on which way you want your scarf aiming. Once you have that figured out, go ahead and mark out the surfaces that are going to be scarfed. Okay, I'll go ahead and scarf these two surfaces off. Rough scarf them out right now off camera. Good enough. I've got the two scarves now roughed in, so we're ready for our final sanding. Take one of the scarves, set the feather even with the end of your 2x6. Because of the strike angle not being 90, we're going to find that our board looks like it's a little bit crooked, but well, never mind, we want to have the feather supported. And we'll set the other board on top. And that's the beauty of this method, is we do line up the edges of the two boards. It makes it easy to line everything up. And we'll move it until the feather of the top board lines up with the strike of the lower board. Then we can clamp that in position. Now let's go ahead and darken in our upper strike line here and duplicate it a couple places. Oops. Remembering that if things aren't lining up, we're going to let this upper strike line migrate, whatever's necessary to get a planar surface here. So everything's the same as in the previous examples. Note though that the slope, which is at right angles to our strike here, is running something like this. So it's not parallel with the edges. So when we go to sanding, there's a tendency to want to sand parallel or at right angles to the board. What ends up then is you end up sanding this edge too fast. So be careful when you're sanding that. Tend to keep the sander running parallel with the dip, not with the direction of the boards. By the way, I noticed a little spring in the upper one, so I put a shim in, steady. Come along. just about there. I've drawn in our dip lines, and you can see, by definition, of course, they're perpendicular to our strike lines here, but they're also perpendicular to the lamina in the plywood as it should be, and not parallel to the edges of the board. So that's an indication that these planar surfaces are shaping up the way they should be. I've got a little bit more to sand to get the feather paper thin, and that should flatten her out. We'll see how it goes. Gluing will proceed pretty much as it did before. Take the lower scarf and clamp that board in position. You may have to support the far end of it if it's a long board, because it'll run off the 2x6, so you'll have to come up with a method for that. The same with the upper board. Once you've got the lower board clamped in position, go ahead and temporarily align the scarves the way you want it. And then we're going to have to double check at this stage by using our pattern to make sure we're on, because just a degree off at the joint here won't affect the joint that much, but it could make a big difference on if the finished board fits the pattern. This is critical that you do that. Once you get it in position, clamp it temporarily, and now we'll go ahead and draw some lines along the sides of your board as witness marks, and then drill the holes as we did before, and then go ahead and proceed as you did when you mixed up your epoxy and glued it. Remember, when you put the second board back in position and pull the shim and lower it down, to make sure that the main portion of the board is firmly clamped in position before you go ahead and apply pressure at the joint with your clamps. That pretty much covers making a kink scarf joint. See you in the next video.